We usually talk about AI as like the ultimate creator, right?
Yeah,
I
absolutely.
mean, it generates art, it writes novels, it builds entire applications from absolute scratch.
Oh, yeah, we see that all the time.
But today, we're looking at AI's most surprising superpower. And it's not as a creator at all, actually. It's as an
An
archaeologist.
archaeologist, I like that.
Right. I mean, have you ever found yourself opening up a file at work, maybe looking at a massive shared spreadsheet or like a tangled project folder that you did not create?
Oh, we've all been there.
You absolutely do not understand it, and you are just terrified that if you change one tiny cell, the entire department is going to collapse.
Yes, the structural integrity of the whole company rests on this one cell.
Exactly. You get that creeping dread, the sweaty palms, just staring at a screen full of decisions made by people who left the company like 5 years ago.
It is a profound and universal dread. I mean, we all inherit these fragile structures.
We really do.
And the standard corporate response is usually just this very casual, hey, figure this out and add this new feature by Friday.
Just casually by Friday, no big deal.
Right. You're essentially told to go operate on a patient without knowing their medical history at all.
Which is exactly the nightmare we are diving into today.
Yes, it is.
We're exploring a really fascinating piece from Aaron Rose. It was published on tech-reader.blog, and it's titled The Secret Life of Claude Code, the Legacy Codebase.
It's a great read.
It really is. And the format here isn't, it's not a dry technical manual. It's written as a dramatized narrative.
Right, like a short story almost.
Exactly. A short story that makes the abstract fear of old, undocumented code incredibly tangible.
Rose sets the stage so beautifully, too. Like, we are placed in this grand Victorian library in London on a freezing, dark winter night.
Very atmospheric.
So atmospheric. It's a room where craftsmanship is literally the only thing that matters. And we meet Margaret.
Margaret.
Yeah, Margaret is this deeply seasoned, totally unflappable senior software engineer. And she's there with Timothy, her junior colleague.
Right.
And Timothy just comes stamping in from the cold, looking completely defeated by a system he's just been assigned to update.
Which brings us to our mission for this deep dive. We are going to see how they tackle that defeat. We're going to look at how Timothy uses an AI tool, specifically Claude Code, to survive this terrifying excavation.
And this is the key part.
Right. Crucially, he isn't asking the AI to write massive amounts of new things. He is using AI to read the unreadable.
I mean, the contrast between that cozy fire in the library and the cold reality of Timothy's assignment is just stark.
Yeah.
He sits down with Margaret, and he describes a 12-year-old legacy system. Now, think about the passage of time and technology, right?
12 years is like a lifetime.
12 years is the Paleolithic era.
Literally.
Entire paradigms of how we build things have been born and died in that time frame.
Yeah, completely.
And over those 12 years, 3 completely different teams have touched this system. They've just been layering their own conflicting styles on top of each other.
And the original architect, the person who actually understood the foundational logic, vanished 8 years ago.
Long gone.
Long gone. And the documentation is basically a trap.
Oh, it's worse than no documentation.
Right. The only written guide is from 2019, and it describes a version of the system that was replaced long ago.
So it's actively lying to him.
Exactly. It's not just unhelpful, it actively lies to you.
Yeah.
And now Timothy has to add a moderately complex new feature that touches 3 separate subsystems. He's been reading code for 4 days, and he admits he only understands maybe 40% of it.
Which means the remaining 60% is just this dense fog of unexplained decisions.
Totally.
And at the center of that fog is a very specific monster.
Okay, let's unpack this. Because Timothy introduces Margaret to the ultimate source of his dread.
Oh, this card is so relatable.
It is a single block of code, okay, a function that is 430 lines long.
It's just massive.
Massive. It has 0 comments, no notes, no warnings. It hasn't been touched in 6 years.
Wow.
And its name is simply process data.
Process data. A name so spectacularly vague it borders on the absurd.
It means nothing.
It means absolutely nothing. But Margaret's reaction is brilliant. She calmly says she knows that function.
Right.
Not that specific one, obviously, but she knows it.
Yeah.
Because every system, whether it's code or, a messy Google Drive you inherited from a predecessor, it has a process data.
Right. It's universal.
It's the dark corner where logic goes to die and nobody wants to shine a flashlight.
And Timothy tries to explain the psychological toll of staring at it.
Uh-huh.
He compares the experience to arriving in a strange city you've never visited and immediately being forced to give a tourist directions.
That's a great way to put it.
Yeah, you can see the streets, you see the buildings, and whoever built them had a plan. But you don't know why a road bends at a weird angle.
Or why a skyscraper is next to an empty dirt lot.
Exactly. You are seeing the physical reality without any of the historical context.
But Margaret immediately upgrades his analogy. She tells him, no, it's not a city.
Right.
Because a city is alive, right? You can stand on a street corner and just watch traffic to figure out how it flows.
That makes sense.
A legacy code base is an archaeological site. The civilization that built it is dead and gone.
Wow.
The artifacts are sitting in the dirt, but the context is totally lost.
That reframing changes the entire nature of the job, doesn't it?
It really does. It highlights why this task paralyzes developers.
Yeah.
I mean, Timothy isn't just an archaeologist asked to document some ruins.
Right.
He is being told to excavate the site and build a brand new skyscraper on top of it simultaneously.
Oh, man.
And he has to do it without disturbing the ancient, invisible foundations beneath him.
But, knowing it's an archaeological site doesn't actually help Timothy write his code today.
No, it doesn't.
So how does he actually start digging without breaking the artifacts?
Well, Margaret gives him the golden rule of legacy systems, which is you read before you touch.
Ah.
And Timothy had a good instinct here, to be fair. He didn't just start hacking away at the code.
Yeah, he was careful.
He started at the system's entry points and traced the logic inward. But human reading has a ceiling.
For sure.
When you are looking at 12-year-old logic filled with dead ends, your brain simply runs out of working memory.
Here's where it gets really interesting. Because Timothy brings Claude code into the process at this point.
Yes.
But he doesn't say, hey, AI, build my new feature. That's what we usually expect, right?
Exactly.
Instead, he pastes sections of the ancient system into the prompt and asks the AI to explain what it is looking at.
Mm-hmm.
Now, playing devil's advocate for a second, isn't Claude Code just acting as a glorified dictionary here?
How do you?
Well, if I feed it Spanish, it gives me English.
Yeah.
If I feed it code, isn't it just reading the syntax back to me in plain text?
That is the most common misconception about using AI for code review, honestly. But Margaret points out a crucial distinction.
Okay.
It isn't translating syntax. It is recognizing structural patterns.
Oh, interesting.
Claude Code is providing Timothy with vocabulary. It looks at the shape of the code, not just the individual lines.
Let's make that concrete for a second. When Timothy feeds that terrifying 430-line process data function into Claude, what does he actually get back?
Well, the AI analyzes the massive block and tells him, this looks like a pipeline processor with manual state management.
Pipeline processor with manual state management.
I know, it sounds intense.
It sounds like impenetrable jargon to anyone outside of software engineering.
Let's break down why that specific phrase is actually a total revelation for Timothy.
Please do.
Manual state management is a very old, very painful way of doing things. Imagine you were watching a movie, right?
Okay.
Yeah. But every time you want to pause it, you have to physically write down the exact timestamp on a sticky note.
Ugh, that sounds awful.
It gets worse. When you want to resume, you have to type that exact timestamp back into the player. And if you lose the sticky note,
You're starting over.
the movie starts over from the very beginning.
Well,
That is
yeah.
manual state management. Modern systems do all of that automatically behind the scenes.
So Claude is essentially carbon dating the artifact.
Exactly.
It's looking at this messy tool and saying, this is a 14th century water jug. They designed it this weird way because they lacked modern firing techniques.
Yes, that is a perfect analogy. Because AI has encountered millions of lines of code. It's seen far more architectural decisions and weird historical constraints than any human could see in a lifetime.
That makes total sense.
It recognizes the era and the limitation. And Timothy admits that knowing the name didn't make the 430 lines less fragile.
Right, it's still a mess.
It's still a total mess.
Yeah.
But Margaret points out the psychological victory here. It made the code less mysterious.
Less mysterious.
And you cannot work safely in a system you find mysterious.
You can only work carefully. And as the text points out, careful is not the same thing as safe.
Not at all.
Moving carefully just means you are tiptoeing slowly through a minefield. Making the code less mysterious means you are actually starting to draw a map of where the mines are.
But a map of the mines only tells you what is there. It doesn't tell you why the minefield was planted in that specific shape in the first place.
Right.
And that brings us to the next phase of Timothy's excavation.
Yeah, because naming the monster doesn't tell you how to slay it. You need to know the intention behind it before you go and change it.
What's fascinating here is Margaret's framework for finding that intention. She introduces the art of forming hypotheses.
Hypotheses.
Right. When you encounter a bizarre decision in an old file, you cannot assume the person who wrote it was an idiot.
Even though we all want to.
We all do. But you have to ask, what specific urgent problem was this solving a decade ago? What bizarre constraint forced their hand?
And Timothy uses Claude Code to navigate this, but not by asking for the absolute truth. Because, the AI cannot read the mind of an architect who quit in 2018.
No, of course not.
Instead, Timothy shows the AI the confusing code and asks it to propose 3 possible historical reasons for why it was written this way.
That prompt strategy is just brilliant.
It really is.
It takes a terrifying infinite space of unknowns and narrows it down to 3 plausible, testable theories. You can then look at the rest of the system to see which theory holds water.
I want to push back on this assumption a little bit, though.
Okay.
Like this assumption that every weird piece of code has a noble historical reason behind it, because Timothy brings up a great example from his own screen.
Oh, the caching layer.
Yes. He tells Margaret about a caching layer, a temporary data storage system, basically, that just seems fundamentally broken. Sometimes the data expires in 2 hours, and then sometimes it literally never expires at all. So he asks Margaret, what if my hypothesis is just that the original code is garbage? What if it's just a bug?
It is the most tempting conclusion to jump to.
Yeah.
But Margaret introduces what might be the most vital concept in the entire piece.
And that is
the load-bearing workaround.
The load-bearing workaround. That phrase paints such a vivid picture.
Doesn't it? Think about a house that has been haphazardly renovated over 50 years. Let's say that original caching layer really was just a bug. It was supposed to delete data every 24 hours, but because of a typo, it kept data for 48 hours.
Simple misstate.
Right. The original developer missed it. But a year later, a totally different team comes along to build a monthly reporting tool.
Oh, I see where this is going.
They notice the data sticks around for 48 hours, so they build a reporting tool relying on that exact delay.
So the bug became a foundation.
Exactly. Fast forward 10 years, 10 different subsystems now secretly rely on that quote-unquote broken 48-hour cache.
Wow.
If Timothy comes in, sees the 24-hour rule in some old documentation, and quote-unquote fixes the bug to make the code correct.
He accidentally knocks down a load-bearing pillar, and the roof caves in on the reporting tool, the billing system, and who knows what else.
Yes. This is exactly why treating old systems with immense respect is non-negotiable.
Right.
The original bug mutated into a structural feature. If you don't form a hypothesis and test it, your fix becomes the new disaster.
So, okay, we are armed with AI-generated vocabulary. We are forming historical hypotheses, and we are tiptoeing around load-bearing bugs.
Sounds like a solid plan.
But eventually, the clock runs out on studying the ruins. Timothy actually has to build his new feature.
Right, he has a job to do.
How does he know when he understands enough to actually start digging?
Well, Margaret sets a standard here that should be a massive relief to anyone listening who deals with inherited messes.
Good, we need some relief.
She tells him that complete understanding of a legacy system is a total myth.
A myth.
You will never achieve it. The standard you are aiming for is simply sufficient understanding.
Sufficient understanding, meaning just enough to add your piece without breaking the adjacent artifacts and leaving the site slightly cleaner than when you arrived.
Exactly. But this requires a major perspective shift regarding the people who came before you.
So what does this all mean? To me, it boils down to empathy.
Empathy, yes.
If you've ever inherited an Excel tracker with 30 hidden tabs and broken macros, your first instinct is usually just white-hot rage at whoever created it.
Oh, definitely.
You just want to curse their name.
It is incredibly easy to assume malice or incompetence. But Margaret beautifully dismantles that instinct.
How so?
She tells Timothy that nobody wakes up and decides to write unreadable 430-line functions.
That's true.
They were just people. People under intense time pressure, probably staring down a Friday afternoon deadline set by an executive who didn't understand the complexity of the ask.
They told themselves they would come back on Monday and add comments.
You all say that.
We do. They promised themselves they would clean it up. But Monday brings a completely new fire to put out.
Always.
Legacy code isn't a record of stupidity. It is a fossilized record of time pressure and shifting business priorities.
And approaching the code with that kind of empathy completely lowers your defensive posture.
It really does.
But empathy doesn't automatically write the new feature. Timothy still has to alter process data.
Right, he still has to face the monster.
So Margaret gives him a highly tactical approach for dealing with it. She tells him to ignore the messy 430 lines in the middle and focus entirely on the contract.
Let's demystify the contract for a second.
Okay.
Think of a function like a vending machine, right?
Okay.
The contract is the explicit agreement of how it operates. I insert a dollar bill and a can of soda comes out.
Simple enough.
I do not need to understand the complex mechanical gears, the refrigeration unit, or the coin sorting laser inside the machine.
No, you don't.
I just need to know the input and the expected output.
That is the perfect way to look at it. The outer shell, the interface, is usually much easier to understand than the internal gears.
Yeah.
Margaret tells Timothy to map out exactly what data process data asks for and what it claims to spit back out.
But she adds a brilliant caveat. She says, if you map out that vending machine and you discover that when you put in $1, it occasionally spits out a live pigeon instead of a soda.
Then you have struck gold. Because you just found a violation of the contract. The system says it does one thing, but the internal gears are secretly doing another.
Right.
Documenting that violation is a massive leap forward in understanding how the system actually behaves in the real world, rather than how it was supposed to behave on a whiteboard 12 years ago.
If we connect this to the bigger picture, Margaret leaves Timothy with a final metaphor that really transcends software.
It's so powerful.
She tells him that working in these inherited systems is a relay race.
But the baton they're handing off to the next generation isn't the code base itself.
No, the baton is understanding.
Yes.
Margaret explains that the baton gets heavier with every single handoff if left untended. If a developer rushes in, slaps a new feature onto a load-bearing bug, and leaves without writing down a single note, the mystery deepens.
And the next person inherits a heavier, more terrifying burden.
Exactly. But the baton gets lighter when someone takes the time, even under immense pressure, to record what they discovered.
You are never going to understand the whole system. But after you successfully add your feature, you will understand a fraction more than you did when you started.
Definitely.
Taking 5 minutes to write that down is your contribution to the civilization of that workspace. It is an act of professional generosity.
It really is. So let's synthesize the core insights we've pulled from this deep dive.
Great idea.
Whether you are dealing with a software architecture, a convoluted corporate onboarding process, or a decade-old shared drive, the rules of the archaeological dig apply.
Right.
You have to read before you touch. You can leverage AI tools not to bypass the work, but to grant you the vocabulary you lack and to generate hypotheses that shrink the unknown.
And you must tread carefully around those load-bearing workarounds.
Absolutely. The ones that look like errors but are actually structural pillars. And above all, you owe empathy to the stressed, time-crunched predecessors who get the ruins you are standing in.
The way Aaron Rose ends the post really brings the whole emotional arc to a close.
Oh, I loved the ending.
Yeah. Timothy finally stands up, wraps his scarf around himself, and pushes out through the heavy doors of the library into the freezing winter night.
Ready to face the elements.
Exactly. But he isn't defeated anymore. He has a plan. He is going to tackle process data by mapping its contract, using Claude code to propose theories.
And Margaret.
Meanwhile, Margaret stays behind in the warmth of the library, writing in her notebook, adding a few more notes to that vital, continuous record of things understood.
It's a fantastic image. But Margaret gives Timothy one last piece of advice before he walks out into the cold. And I think it is the perfect challenge to pass on to you, our listener.
It really is.
She tells him, when you find the thing that makes it suddenly legible, the strange decision that explains all the other strange decisions, write it down immediately.
Immediately.
Before you check your email, before you move on, that moment of understanding is the most valuable thing you will produce today, and it will not last as long as you think.
It's such a sobering truth. That flash of clarity, the moment the fog parts, is incredibly fragile. Your brain will overwrite it by tomorrow morning.
It absolutely will. So think about the systems you have to navigate every day. The inherited messes, the bizarre approval workflows, the spreadsheets held together by duct tape.
We all have them.
What are the load-bearing bugs holding up your daily routine? And more importantly, when you finally crack the code, when you figure out why that strange process exists, what do you do next?
That is the question.
Do you just use that knowledge to quietly finish your task, letting that fleeting moment of understanding vanish into the fog? Or do you take 5 minutes to write it down, to document the contract, and lighten the baton for the next person running the relay?